of human beings. Without time, you don't exist. What if you could gain 1,000 hours worth of time in one day? What is the essence of time? You must understand the idiosyncrasies and the peculiarities of time. Imagine time being an Excalibur sword that can cut through the fabric of space. You must fathom the existence of time's true identity if you want to ever uncover the secrets and mysteries of the world. If you truly want to unlock 100% access of the brain, you're going to have to be able to imagine the unimaginable, dialectical, and unfathomableness scale of time itself. You have to solve the mystery of time before you can come to an ultimate conclusion about the nature of the intergalactical catacomalistic realities of the world.
Albert Einstein's theory of relativity is one of those theories you want to understand because it gives you understanding on space and time, how they actually work and how it actually corresponds one to another. Albert Einstein was not only known for his theory of relativity, he was also known for his writings on the photoelectric effect, which that led to light meters, solar panels, and photographs. He was also known for developing the famous formula E equals mc squared, which that led to the invention of the atomic bomb. He did writings also on the Brownian motion, which that depict the random movement of particles, in which that led to quantum mechanics. Him and another physicist developed a model of what a wormhole would look like, if you know what a wormhole is. He theorized the existence of gravitational waves, and he formalized the existence of black holes. So Albert Einstein did a lot of stuff. He made a lot of major contributions to science. I'm just going to elaborate off the theory of relativity, but if you were to learn from all of his scientific papers, formulas, and ideas, you definitely would be a lot smarter than you are right now. And besides, most of these formulas and theories aren't very difficult to understand anymore because we have YouTube, we have people on YouTube now breaking down his formulas. Anybody can understand them. So if you were to take his understanding of these formulas that he has, you may be able to take it to a greater understanding. Just maybe. Most scientists today do believe that time travel is possible, thanks to Albert Einstein's theory of relativity. If you kept up with the physicists and scientists today, you would already know that. So where have you been? But don't worry, I suppose I'll put on a video so you can at least try to catch up to the science on time travel today.
Is time travel possible?
We can definitely travel into the future by moving faster relative to everybody else. The tricky part comes if you want to go into the past. And that's really dangerous. It is so dangerous that Hawking was thinking to himself that there must be some law of physics we have yet to discover that prevents it. Because if you go back and prevent your parents from meeting each other, then you will never be born to go back in time to prevent your parents from meeting each other. So yeah, it might not be likely that we can do this, but there are equations in the general relativity that allow it.
In that case, time travel is something you have to take very seriously, because Einstein's equations do allow for time travel.
Yes, sir, and yes, ma'am. Time travel is a real phenomena. It's not just science fiction anymore. Thanks to Albert Einstein's theory of relativity, thanks to his scientific breakthrough on space and time, once you begin to understand that Albert Einstein's theory of relativity, you'll be able to understand all the movies that depicted time. You know, the movies that show time slowing down and people going back and forth in time. You'll be able to understand that completely. Here's the definition on the theory of relativity.
It turns out, time slows down when you travel faster and faster, nearing the speed of light. So, the faster Einstein travels, slower the time passes for him. Hence, what could be a day for Einstein in space could be as much as 50 years for you on the ground. This became the fundamental conclusion of the theory of relativity, a theory proposed by Albert Einstein in 1905. This theory broke the traditional understanding of time as a constant entity and proved that time, in fact, is different for different observers.
Part 2. Special theory of relativity, time dilation. The second thing we need to accept is that the speed of light is the same for all observers. So, let's imagine a beam of light being reflected between two mirrors. Let's replicate this setup so we have another beam of light being reflected between another set of mirrors, but this time the mirrors are moving close to the speed of light. We can see in the moving set of mirrors that the beam of light is moving a greater distance. Now, let's put a couple of people into this scenario. Meet Alex. He sits inside the moving set of mirrors, and Bill sits inside the stationary set of mirrors. The speed of light must be the same for both Alex and Bill, and their light beams must hit the bottom mirror after the same amount of time has passed. But, as Alex's light beam is covering a longer distance, how is that possible? Well, the only way for that to work is if time for Alex slows down. Look at the clock hand. Notice how Alex's clock hand is moving much more slowly compared to Bill's. Time for Alex has slowed, which allows his light beam to travel a greater distance. Look at it this way. Speed equals distance divided by time. As Alex's distance is more, the value of his time must be more. Or rather, Alex's 1 minute actually turns out to be longer than Bill's 1 minute when you compare the two. Time has slowed down for Alex. This is called time dilation. This is quite a hard concept to grasp because it seems to go against what we experience on a practical level. But to understand the theory of relativity, you must stop thinking of time as a fixed unit for everyone. Time is relative. Confused? Don't worry if you don't grasp all of this immediately. Remember, it was the most brilliant scientist of the 20th century who put forward this theory.
So let's look at a mathematical equation and a formula that depicts Albert Einstein's theory of relativity. You should have learned this formula here on the wall in school or in college, but if you forgot, it's right here on the wall. And that's time equals distance divided by speed. And that's how you get the time. So let's say that a mall is 100 miles away and you're driving at the speed of 50 miles per hour. How long would it take you to get to the mall? And we can do simple arithmetic right here. You would just drop down the time here in the equal sign, and you'll divide the distance by the speed, which was, the distance was here, 100, the speed was here, it's 50 miles per hour. You would simply divide 100 divided by 50. This would be 2 hours here. You would just simply drop down the time. So it would take you 2 hours to get to the mall, driving at the speed of 50 miles per hour. Now, if you was going 100 miles an hour and the distance is still the same, how much time would you gain? So you can see here, if you would do the same formula, just bring down the time. 100 miles, distance, that's the distance of the mall. You can speed up 50 miles per hour, so it'll be 100. So simply bring down the t, divide 100 by 100, at least 1 hour. So notice here, you gained 1 hour of time. Now keep in mind, Albert Einstein's theory of relativity that suggests that every time you speed up, you gain time. And time begins to slow down faster and faster you go. And you can see it here in this mathematical equation. So now if you was going 200 miles an hour and the mall still being 100 miles away, and if you do the simple arithmetic here, it will take you 30 minutes of time to get there. Now the total amount of time you would gain would be 1 hour and 30 minutes. Because remember, it used to take you 2 hours to get there. But now, simply, if you take the 2 hours here and add the 30 minutes here, then subtract, it'll be 1 hour and 30 minutes. Now, I think you get it. I think you understand that every time that you do speed up, you do gain time. Get a little bit creative here. Let's divide the distance of the mall, which is still 100, by the speed of sound. And the speed of sound travels approximately 760 miles per hour. Let's see what time would you get there if you were traveling at the speed of 760 miles per hour. Simply here, you would again bring down the t equal sign. The distance is still the same, and you would divide it by 760, bring down the t equal sign, and this turned out to be 7.53. So that's 7 minutes and 53 seconds. So it would take you 7 minutes and 53 seconds to get to the mall. So if you were to divide the distance of the mall by the speed of light, which is the constant speed of 186,000, how long would it take you to get there? So we can simply do this equation. Once again, bring down the t equal sign. The distance is still 100. This is the speed of light, which is 186,000. And this turns out to be 1 second. So it'll take you 1 second of time. So I know like this number is 1. Let's say 58761. It's something like that. I just already rounded it off. I didn't give you the exact number. I'm not a mathematician, guys. I'm just trying to get you to realize the faster you go, time actually begins to slow down. So how much time would you gain now traveling at the speed of light? You would literally gained 2 hours now traveling at the constant speed of light. Now, to be exact, it's 1 hour, 59 minutes, and 59 seconds to be exact.
The speed of light isn't constant.
Does the speed of light actually have anything to do with light? So what is it about the speed of light that's so special? Why does the universe seem to conspire to 1. Keep photons from travelling at any speed but 300,000 kilometers per second in a vacuum, according to any observer, and 2. Keep anything from travelling faster than that speed? The answer? This statement is false, or at least backwards. The universe doesn't arrange itself to keep the speed of light constant. In fact, space-time couldn't care less about light. The cosmic speed limit is about something much deeper. There are hints of something horribly wrong lurking in the math. Actually, 2 hints. The first clues to the bizarre quantum nature of reality had emerged, and, more importantly for this episode, Maxwell's equations had cast confusion on the sacred Galilean relativity. In fact, we now know that even Newton's mechanics were using assumptions that implied an infinite speed of light.
Although the speed of light is measured at 186,000 miles per hour, doesn't mean that the speed of light can only accelerate at the speed of 186,000 miles an hour. Science once again has limited this world and reduced this reality down to mathematical equations and have stripped it of its uniqueness and of its unfathomable scale.
That's a very interesting deductive postulation there, Anonymous. So why isn't the speed of light constant?
Because all elements are in seed form. One seed can grow into one gigantic tree. One would have to know the full depths of the quantum mystical inductive understanding of the elements to know its true dynamical power and ability. For example, wind can be used to generate electricity. Air can be used for energy. Air can be used for medicine. Air can be used to power a car or an airplane. In one environment, air can be cleaner and healthier than another. The more cleaner and healthier the air is, the more energizing and conducive it is for you. When air is accelerated, it becomes a sharp blade that can cut even through stone. One can conclude that air has many forms. For another example, look at water. Water also has many forms. Scientists do not understand the uniqueness of water and its complexities. Water has baffled many scientists. You see, water has different effects and hydraulic manifestations. When water receives advanced deductive information, it transforms into another form. Water can be used for energy, for saving information, transporting information, and interpreting information. Oh yes, water can interpret information. You see, Chris, when water is accelerated, it becomes a sharp blade. See, accelerated water is a different form of water that has strength and speed. Water has untapped and unrestrained multi-dimensional meta-hydraulic power inside of it. The knowledge of water is so esoteric that the world would take 1,000 years just to fathom its uniqueness. So now let's look at light and its peculiarities. Scientists can only measure the speed of light, but they cannot measure the transfigurative and the hyper-oscillatory ability of light. No one knows the full capabilities of light, you see. Light can be used for energy, such as batteries, solar panels, and transparent cables. Light can be used to make laser beams, augmented reality, and virtual reality. So one can conclude that light can be accelerated, just like water and air. Therefore, the speed of light is not constant.
I think I get it. So light, air, and water can be captivated, transformed, and accelerated, which changes its forms. Nice. I like it. I like it.
So let's look at your example that you gave on the board. If you were to go 20 times the speed of light, or speed of infinitely, you would still continue to gain time. This would also create a rift in time, or an intergalactic bubble of time. Picture it like this. There would be this circle of time where you would be able to go back and forth and up and down in time. You now would be able to bend the time, not break time or control time. Time is just slowing down for you. Time is still going on in a linear fashion.
So to elaborate off of what Anonymous said, I'm going to use the same example and use this charts. So just follow me. So let's say it's a point, this is where you at. Let's create a timeline, and let's still say this point is the mall, which is still 100 miles away. So we know if you were to speed up, you would continue to gain time. And traveling at the speed of light, you would literally gain 2 hours worth of time. So if you were to continue to speed up infinitely, you would gain an infinite amount of time. You could gain anywhere from a year's worth of time to 5 years worth of time to 10 years worth of time if you were to continue to speed up infinitely. And when you would speed up infinitely, it would make this intergalactic time bubble here that you would be able to go forward, back, down, up, forward, back, and all over the place in time. So if you would speed up infinitely, and if you would see and look outside and see, let's say, the cars going back and forth, they would be frozen in time because you're going so fast at this point. If you looked up in the sky and saw a plane, it would be frozen in time. If you saw children outside playing at the park or something, that would be stationary and steady. You wouldn't be able to tell that they're actually moving. So this is one of the underlying mechanics of the theory of relativity. We understand space-time now. We know that time travel is possible just by learning and observing the writings of Albert Einstein.
Slowing down time infinitely would formulate and prescribe and suggest that there is an infinite amount of time in 1 second. You see, nobody really knows how long 1 second is. 1 second could be 1,000 years. Christopher Floyd, there is an infinite amount of time in 1 second. There is an infinite amount of time in 1 minute. there is an infinite amount of time in 1 hour. This would imply that there are bigger and greater infinites. There are different kinds and different forms of infinity. This would mean that there are possibly an infinite amount of infinities. Let me say that again. This would mean there are possibly an infinite amount of infinities.
What in the world? An infinite amount of infinities? That doesn't even make sense. Anonymous, it's quite a mind-boggling thought. I've never heard anybody in the scientific community make those type of statements. You deserve a Nobel Bell Prize or something after that thought. Hopefully now, guys, you can understand Albert Einstein's theory of relativity, what has to do with space-time. You should be able to understand now all the movies and shows that depict time travel and time slowing down. You should be able to understand it flawlessly now if you paid attention to what Anonymous in my examples that were illustrated on the board. So stay tuned to the channel. I'm still going to give a more concrete and unique definition to the essence of time.